Hi everyone. We're going to look at how to use the quadratic formula to solve these quadratic equations. Now the formula you can always use for any quadratic equation, it's just not always the fastest method. So if you're not sure what to do, you can always jump to this formula and use it to solve your quadratic. The key is to always make sure it's in we call standard form equal to 0. You always want it to look like ax squared plus bx plus c equal to 0. That way you can figure out what a, b, and c are. Because we need those three for the actual equation, the actual formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we need a, b, and c in order to plug into this formula. So looking at this first example here, we've already got it equal to 0, so we can find a, b, and c. A is the coefficient of x squared, so that's 4. B is the coefficient of the x term, so that's negative 1. Don't forget that negative. And c is the constant, so it's negative 3. Now again, we just plug into the formula. So x equals negative 1 plus or minus the square root of negative 1 squared, don't forget parentheses there, minus 4ac all over 2 times a. And then from here, it's really just simplifying. This gives us 1 plus or minus. Negative 1 squared is 1. Negative 4 times 3. Well, 4 times 3 is 12. Times another 4 would be 48. Two negatives make it a positive, so plus 48 all over 2 times 4, which is 8. And then from here, we're just going to try and simplify further if possible. So 1 plus or minus 49 all over 8. Well, the square root of 49 we can do, that's just 7. So it's 1 plus or minus 7 over 8. From here we can see if we can go a little bit further. You can try to break up the plus or minus. So it's 1 plus 7 over 8, which is 8 over 8, which is 1. Or it's 1 minus 7 over 8, which is negative 6 over 8, which is negative 3/4. So there's our two options for x. We've got the negative 3/4, and we've got 1 using that formula. The fact that these are both rational roots, that tells us that we could have probably factored the original equation if we wanted to, which might have been a little bit tricky because a was not 1, but it is possible since these two are both rational answers here for x. All right, let's do a couple more examples. We've got one more over here. Looking at this one, a good strategy to start with once you got equal to 0 is to look for a GCF. If you got a GCF, it'll make the numbers smaller to work with, so let's do that. These are all even, so we're going to pull out a 2. And that cuts all of our numbers literally in half, which is nice. Now instead of using this a, b, and c, we can use this a, b, and c, because that 2 in front we could just essentially divide by. It doesn't change our answers either way. So now we're going to use the formula with the smaller numbers, just because it's easier to work with in our head too. So x equals negative b, so negative 5. So a is 5, b is negative 5, c is negative 1. Plus or minus the square root of b squared minus 4ac all over 2a. So we get 5 plus or minus, this would be 25. 4 times 5 is 20, so there's those two negatives there make it another positive, all over 2 times 5, which is 10. And this gives us 5 plus or minus, that would be 45. All over 10. So that square root of 45 is not a perfect square, but we can simplify that. The square root of 45, well, we think about, okay, what perfect square goes into 45? What perfect square is a factor of 45? And that would be 9 times 5. So that would be the square root of 9 times the square root of 5, which is 3 square root of 5, which just simplifies the square root a little bit down. That gives us 5 plus or minus 3 square root of 5 over 10. Which, I mean, we could simplify a little bit further from there. It's not going to look super nice, but this is totally fine to leave it like that too. You could make it 5 over 10 plus or minus 3 square root of 5 over 10. This 5 over 10 you could call 1/2, but then that's about it. 3 and the 10 on the bottom don't simplify, and you definitely can't simplify these two things because one's in a square root and one is not. So don't try and do that. So this I'd actually leave just like that as our answer. And that's about it for the quadratic formula. It gets a little bit trickier if you've got it in a form like this where it's not equal to 0 yet, but you really just got to move things around. It's really not too bad. If we just do a minus 6x squared, that's just the one extra step. So, not 11 though. Let's try again. 9x squared minus 10x minus 4 equal to 0. And now again, we look for a GCF if possible. I don't see one. So we find the A, the B, and the C, and plug them in. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Looks really complicated because it is, but there's just a lot of little simplifications to do. So 10 plus or minus the square root of 100. Let's see, 4 times 9, well that would be 36 times another 4 would be 144. So that would be a plus because it's got a minus and a minus all over 18. Okay, well, let's see, this is 10 plus or minus the square root of 244 all over 18. Let's see if we can simplify that further. So perfect squares that go into 244. Well, it looks like 4 is going to work because 4 goes into 24 and it goes into 4. So let's break that up into 4 times something. Looks like that would be 61. 4 times 61 would be 244. And 61 is a prime number, so we're basically done. So that would be 10 plus or minus, that would be that's square root of 4 times square root of 61, which is 2 square root of 61. So 2 square root of 61 all over 18. And then we can go a little bit simpler here if we just divide everything by 2. Because if this is 10, I'll split it up first. 10 over 18 plus or minus 2 square root of 61 over 18. And then just simplify your fractions. So the first fraction, they're both even. We can call this 5/9 plus or minus square root of 61 over 9. Looks crazy. Well, that's the answer. That's our definitely irrational answer because this is not a ratio of integers. Square root of 61 is not going to be a ratio of integers because that's not rational. And one more, very similar. If we just move things around, get it equal to 0, plug into the formula, we'll be done. So let's get it equal to 0. So this is a 1x minus 1x minus 1x minus 6 minus 6. So 8x squared plus 3x minus 9 equals nothing left over here, which is the goal. A would be, I don't see any GCF, so A would be 8, B would be 3, C would be negative 9. Plug them in. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, simplification here. Negative 3 plus or minus 9. Let's see, 4 times 8 times 9. Well, 8 times 9 is 72. I know that one. That times 4 I can do pretty quickly. 4 times 2 is 8. 4 times 7 is 28, so 288, and 2 negatives make a plus, so plus 288 all over 16. And then that would be negative 3 plus or minus 288 plus 9 would be 297. And then we divide that all by 16. And we can think, well, what goes into 297? That's a little tricky. I'm going to go with 9. I think 9 goes into 297. If I'm being creative here, I think it'll work out. Because 270 would be 30, and then you got 27 more. So I'm thinking here if we do a perfect square 9 going into it, this is division, not a square root. So that would be 3 to make 27, and then 27 again, so another 3. So 33. So this would be 9 times 33, which is the square root of 9 times the square root of 33, which is 3 square roots of 33. So it's negative 3 plus or minus 3 square root of 33 all over 16. And believe it or not, you can't go much simpler because 33 is not prime, but it's also not a multiple of any perfect squares. 3 goes into it, but 3 times 11, neither one is a perfect square, so it's not going to simplify the square root at all. Also, 16 is not a multiple of 3, so the 3's up top aren't going to simplify at all with the 16 on the bottom. But if you'd like to, you can write it like this. Negative 3/16 plus or minus 3 square root of 33 over 16. Wow, what a lovely answer. As you can tell, these answers are not going to be as pretty, if you want to call them pretty answers, compared to those you get from factoring, but that's why we have a formula, because you can't solve these two by using factoring, so we have to have another method. You could, of course, use complete the square root 2. That would work too. You should get the same exact thing. But you can always use this formula even when it is factorable. The first one here was factorable, but we were able to get it with the formula without any trouble. And that's the formula, and that's how you use it. You can use it for any quadratic to solve. Once you get it equal to 0, plug in a, b, and c,